so 68% will score between, because that's within one standard deviation. So what's within one standard deviation?
85.
85 to
115.
right? 95% will score within two standard deviations. So that is between what and what?
70
and
130.
Great. And 99.7% will score within three standard deviations. So that is
55.
and
145.
great. Nice. All right, we are done with that handout. Now we're moving on to the next handout. There's the relative standing and box plots. Okay. We're going to look at z-scores and percentiles today and quartiles. So first off, what about z-values? Do you guys remember these symbols? The population mean, population standard deviation, sample mean, sample standard deviation. What are those symbols? Someone give me one. Give me one of those symbols. Anyone? Which one? Which mean? Sample mean or population mean? Sample mean x bar. What's another one? U is the population mean. Someone give me another one. S is the sample standard deviation. Great. And what's the population standard deviation? Sigma. The little circle with the tail. Good.
No.
So which ones are statistics? Which of these are statistics?
One's in red.
The ones in red. The ones for the sample. Good. So these guys are statistics. Which ones are parameters? The ones for the population, P parameters. So that means that mu and sigma are parameters.
Yes.
X bar and S are statistics. Good? Everybody on board with that?
Yes.
Great. Okay, a z-value. So here's an example. 55 plus or minus 10. So that kind of means the mean is 55. My standard deviation is 10, because it's kind of give or take 10, right? So what's my mean? 55, great. How far is 60 from my mean?
Half standard deviation.
But how far, like straight up?
5.
5. Okay, it's 5 from the mean. How many standard deviations is that?
Half.
What, you guys said 1/2. Why? Because if I take 5 and divide by whatever one standard deviation is, I get 0.5. It's sort of like inches, 6 inches. If I want to know how many feet 6 inches is, what would I divide by? How many inches in a foot? 12. I divide by 12. And that will change it from inches to feet. If I want to know in terms of standard deviations, I take how many whatever is in a standard deviation, 10, I divide by 10, and that'll change me to in terms of standard deviations. Right? Like, for example, okay, say it was 36 inches long. I want to change it to feet. 36 inches, what do I do? 36 inches divide by 12, because it's 12 inches in a foot. So whatever you're trying to find, you divide by how many of those is in a standard deviation, if you want to find standard deviation, in terms of standard deviation. So, next one, how about 40? How far is it from the mean? 15. Is it above the mean or below the mean?
Below.
So it should be negative 15. Everybody with me?
Yes.
So how many standard deviations is that?
1.5.
Negative 15 divided by 10, negative 1.5. So that's its z-score. Z-score 40 is negative 1.5. The z-score 55 is positive 0.5. Yeah, that'll take a minute. All right, so let me say this so you guys can hear it. A z-score represents the number of standard deviations a value is above or below the mean. It's a measure of how far from the mean it is. This is super important. It's so important that you guys are going to have to repeat it on the exam. I will say, finish this sentence as I have written it in class, and I will write a z-score represents and a line. and you'll write the number of standard deviations a value is above or below the mean. Don't worry about the parentheses, just the other part.
So you have to write
Again, I'll say it one more time. A z-score represents the number of standard deviations a value is above or below the mean. I can say this in my sleep apparently because I'm said it so many times. Okay. Yes.
So like, can we use everything we worked on from the last worksheet? You could call that a z-score.
What's that?
Everything we worked on the last worksheet when we were doing like figuring out normal distribution, the distance between the mean is a z-score.
Okay, so think if it's within 2 standard deviations, so if you went 2 standard deviations away from the mean, then your z-score is 2. If you went 2 standard deviations below the mean, then your z-score is -2. So yeah, those sort of were z-scores when we're counting how many standard deviations away we were. Okay. Here it is again. Again, I repeated it in a box because it's super important. So we're going to say this first part, not the parentheses, but the first part together. You guys ready? 1, 2, 3. A z-score represents the number of standard deviations a value is above or below the mean. Good. You will need to know that for the exam. It will literally be on the exam, right? Finish this sentence as I've said it in class. Also note that for any specific variable, for any problem basically, each value has exactly 1 z-score, and each z-score corresponds to exactly 1 value. So for example, if a team height was 66 with a standard deviation of 4, the value of 64 inches has a z-score of -0.5. And also, the z-score of -0.5 has a value of 64 inches. Those match up, right? They kind of mean the same thing. They mean the same spot. They both mean, both 64 inches and z-score of -5 mean the same spot, kind of in the number line, or the, your place. How do we find it? Well, what did we do? We took the value, we subtracted the mean. That's what we did, right? How far is 55 away from the mean? We subtract the mean. That way, if it's above the mean, it's positive. If it's below the mean, it'll be negative. Then, we divide by standard deviation to get it in terms of standard deviation. Symbolically, you write it as z equals x minus mu over sigma. If it's for a sample, fill this part in. For a sample, you'll write z is equal to x minus x bar, right, the sample mean, divided by s, the sample standard deviation. So it should go right in here below the lines where you filled in the other blanks. It should go right in, right here on the side. Right here. Next to, yeah. Now let's try it too. All right, so a couple comments. Whenever a value is less than the mean, its corresponding z-score is negative. All right, so if it's below the mean, it should be negative. If it's above the mean, its z-score should be positive. Typical values are within 2 standard deviations. So if I have a z-score of -2 up to a z-score of +2, those are kind of ordinary or usual. Anything less than -2 or a z-score that's larger than 2, those would be unusual. A z-score less than -2 or above +2 would be unusual. All right, so these are, if you look at the picture, the red ones are unusual, the green ones are ordinary. Okay, so heights of a woman on a soccer team have a bell-shaped distribution, mean of 164 centimeters, standard deviation of 7. Candace has a height of 178 centimeters. Is she above the mean or below it?
Above.
Above how far?
268.
178 minus 164. 14. How many standard deviations is that? 2. Great. Jenny has a height of 169. What's her z-score? Well, I take her height, I'm going to subtract the mean divide by standard deviation. Call it Z of Jenny. And I'll get 5 divided by 7. Yep, 714. Okay. Let's do this next one kind of together. Laura has a height of 152. Everybody find her z-score. Z of Laura. Find it.
I didn't quite catch the guidelines for unusual.
Oh, she's within 2 standard deviations. So usual is within 2 standard deviations. If you're less, if a z-score is less than -2 or greater than +2, you're unusual. All right, so Laura, 152 is her x value minus the mean, right? Because it's x minus x bar divided by s. So x is 152, that's your value that we care about. The mean is 164. Standard deviation is 7. Negative 12 over 7, which is negative 1.714. Okay, you guys have on any paper to do lab problem 2. Steve's height, do it. One minute, do it. Try to do it in 1 minute. Again.
Do we have to change their height to the same?
Okay, so we'll take a look at Steve. The z-score is going to be 63.7 minus 67.4 divided by standard deviation 2.6, and you guys got what? 1.422? Good? All right, z-scores, I want 2 decimal. Typically people do 2 decimal places on that. Is Steve's height usual or unusual? Usual. Usual, because it's within 2 standard deviations, right? So between -2 and +2, those are the usual values. We talked about that before, how our minimum usual value was 2 standard deviations below. Our usual maximum is 2 standard deviations above. So those are kind of the boundaries for usual. All right. On your sheet, you also have guideline for unusual. What's our general guideline for unusual? What percent or less?
5%.
5% or less. All right, then we got percentiles. Percentiles are measures of location. There are 99 of them, denoted P1, P2, P3, all the way up to P99. They split our data into 100 groups with roughly 1% in each group. Here's the problem with percentiles. They're meant to be used with thousands of pieces of data. We're not going to give you thousands of pieces of data. We're going to give you like 40 or less. So it's really hard. You know, there's 3 or 4 different ways of calculating these. And if you're talking about thousands of pieces of data, they're all roughly the same. But when you're talking about 40, it's kind of a big difference between them, which is a little bit tough. But we're going to do our best with it. finding the data percentile for a data value. So the percentile is the percent of people that you beat, percent of people that you're higher than. So I'm going to count the number of values I'm larger than, the number of people values that I beat, how many people I beat, and then find what percent of the total that is by dividing by the total number of people and then multiplying by 100%. Here's an example. 23. I want to find the percentile for 23. So here's 23. How many people are lower than it? All these guys are below it. This guy's not below it. He's the same as it. You want people that are below you. So there's 10 that are below me. So I beat 10 people. 10 people out of how many? 10 people out of 40. That's 0.25. If I'm going to express that as a percent, that's 25 cents. So it's 25%, which means that it's 25th percentile. Percentile is another kind of word to use in place of the word of the symbol percent. Everybody all right with that? You guys do lab problem number 3. Pause this video until you finish that, and then start it again. Okay, so here's me, the last 25, and I beat all of these people here. How many is that? Well, each row is 10. I beat 22 of them. So I beat 22 out of 40. So that's 0.55. To find the percentile, I just move the decimal place over 2, right? Because how many cents? This is how much cents? This is 55 cents. That means I'm in the 55th percentile. So that's the easy way of changing from decimal to a percent, is to say, okay, here's my cent spot. So it's 55%. So the 55th percentile. Great. All right, good deal. Now, your book will do it slightly differently. So I'm going to give you the book way. For homework. Your book says that it splits you in half. So it says that you beat half of you and half of you is above you. Does that kind of make sense? So it's saying, here's me, half of me is below me, half of me is above me. So it kind of counts, so it kind of counts you beating half of yourself. So it would say that you beat 22 and a half people. Does that sort of make sense? So that's, the book way would be, you beat a half of yourself. So it's 22.5 out of 40, which is, I think, 0.57 maybe? 5625 or something like that? Help me out. 2.5, 625. So it's 56th percentile. Does that seem all right? Is everyone good with that part? Yeah.
Why do you beat half of yourself?
Because it's saying, here's me right here. Half of me is below me and half of me is above me.
Oh, okay. Yeah, they're splitting the data.
Yeah, it's splitting me in half. And saying that right here, half of me is below me and half of me is above me. Yeah. Yeah.
So on the homework, you're basically just adding a half.
Yeah, exactly. On the homework, you're basically adding a half to whatever, how many people you beat at a half. I believe I'm 95% sure that that's how your homework does it. It does it definitely one of these two ways. Yeah. You guys, I can't hear her. What?
Is it kind of the same as thinking of it as like those are the boundaries?
Yeah, it gets a little messy because your boundary should be right down your middle. But yeah, it's just.
Like with the half, then it's like kind of like the boundaries. Because you know how like.
Well, yeah, it is sort of like, yeah. So think of it, yeah. Yeah, we can talk about that a little bit later. But yeah, it's sort of, it's if that helps you think about it, then that works. Here's the thing. Working backwards, we have to, how do we find the percentile? we took the number of people we beat, which they call L. We divided by the total number we had, right? So K is our percentile. And we multiplied by 100. How do you undo that? You multiply both sides by N, and divide both sides by 100, and that gives you this part right here. Right? You take K, you divide by 100, multiply by N, and that's how you solve for L. So it's not a new formula, it's the same formula, just rewritten. So in other words, if you want to flip it around and solve the other way, then L gives you the number of people that you beat. Does that make sense? So here, I'm going to look at this. So here's an example. Here's all the people. First, put them in order. Otherwise, it doesn't make any sense. And then remember this part here. I need to find the part that corresponds to 25th percentile. So 25% divided by 100, multiplied by n. How many of them are there? 10 of them, multiplied by 10. That will tell me how many people are lower than me. So let's see, that's going to be 2.5. So I beat 2.5 people. 2.5 people, it means I beat this person, I beat that person, I'm right there. In other words, in a sense, I beat everybody up to 3 people. I'm the third person. So I beat up to 2.9 people even. So you beat anything less, if I'm the third person, I beat anything less than 3 people. Are you guys all right with that part, that concept? So that's how your book is going to work it. You beat if you're the third person, you beat everybody up to 2.9 people, up to 2.95 even. Here's a little bit nicer. All right, so the last thing you guys have to do is this lab problem. Find the percentile. You know what? I'm not going to worry about that. We'll do that one later. I want you guys to look at this first. I still have 2 minutes. Relax. I want to talk about quartiles. So quartiles split your data into quarters. There's 4 quarters in $1. So how do you cut this? You make 3 cuts, and that splits it into 4 pieces. Q1, Q2, and Q3 split it into 4 equal spots. Q2 is the same thing as the median. Q1 is the median of the lower half, and Q3 is the median of the upper half. So if I want to find the quartiles, it's super easy. Arrange your data in order from smallest to largest. Split your data perfectly in half. Find the median of the lower half, that's your Q1. Find the median of the upper half, that's your Q2. If you have an odd number of data values, then you can't split it perfectly in half. So you leave out the middle value, and you take everything else, the lower half. That's the median of that is your Q1, and the median of your upper half is your Q2. So that's the basics of that, and we will go over some of those next class. All right, we'll see you guys on Thursday.